risk return analysis using a Jupyter notebook in Python, and I'm importing my stock data from Financial Modeling Prep, and I'm importing my cryptocurrency data from Coinbase Pro. Each are going to be daily closing prices. So let's get started. First, I'm going to load my API that I wrote from crypto data import stocks and crypto. I don't know why I named it crypto data. I guess I have more of a bias towards crypto. Okay, there's that. So now we want to define our stock tickers and crypto tickers. So stock's going to be Apple, Google, Netflix, Amazon, Microsoft, Goldman Sachs, JP Morgan. Now my crypto tickers are going to equal, of course, BTC USD. And by the way, all the cryptocurrency are in pairs, so that's why we're putting BTC USD. That's how you import it from the data source, Coinbase Pro. So of course, ETH USD, Litecoin USD, Sol USD, Ethereum Classic USD. How many do we got? 1, 2, 3, 4, 5, 6, 7. Two more cryptos because I want to keep it even. Zcash USD and Link USD. Let me go ahead and print out the links too, just to make sure we're good. Yep, both got 7. Now time to import the data. So I'm going to call this stock data equals stocks stock tickers, and then crypto data equals crypto tickers. Now importing all the data is going to give us that. I guess it printed all of them. Do a quick check. Okay, yeah, we got our Apple data. What else? Google, Microsoft. Let's print the crypto data. We have the same type of format. Link, Ethereum Classic, Litecoin. Okay, so we know our data is imported now. Now what we have to do is extract the close prices. Oh, and by the way, can't really make this go away, so I guess we'll just have to deal with it. But yeah, the close prices. So stock close equals for ticker in stock tickers. Is that what we called it? Yep, stock tickers. So what we're going to do here is our data frame is stock data. And it's indexed with the ticker. Now we want adjusted close dot values dot to list. So it's going to order in the sequence of tickers. And now crypto close crypto data ticker close capital. It's a little different. Okay, so we got that. Let's print that out, see what it does. Okay, so we got everything in the list now, and let's just make sure crypto worked as well. Yep, got everything ready to go. So, okay, what's the next step? Oh yeah, we need to extract the time from each stock and crypto, because that's how we're going to align the data sets together. So stock time will equal stock, I'm just going to use the default ticker, stock data dot apple date dot values dot to list. Let's see. Okay, perfect. That prints out. Now we're going to do crypto time. Crypto data BTC, USD, Apple, and Bitcoin. Time dot values dot to list. I'm going to show you what we're going to be doing next in a second. Okay, so now you see how the dates were two different formats. To be clear, let's print out the first element. So that's stock time. This is crypto time. Okay, so you see how stock goes from year, month, day. Crypto goes from month, day, year, and includes the time. We want to convert crypto timestamp into stock timestamp format. So in order to do that, I'm going to create a function called def match dates. And we're going to include our arguments as the stock close, crypto close, stock time, crypto time. And we're going to create another function within called converter, so we can convert all of our values. So I'll just do that as II. So R equals, we need to split the space to get rid of the time. It'll be II.split space and get the 0 argument, because this is the 1 argument. We don't want the time. And we're going to call S equals R.split, because R is still a string. We're going to split it by the hyphens and make another variable called T. This is going to be our new date storage. So we need to store it in year, so that would be S -1, month, which is S0, and day, which is S1. Now return time. So now we're going to do DW, I'll just call it, oh no, yeah, DW equals for T in crypto time. Do converter T. So now that we got that, let me go ahead and call this function too, so we could see them. It's all a list. Yeah, I'll worry about that later. I'll just do stock close, crypto close, stock time, crypto time. Okay, so I want to print out DW. Oh, what do you know? They match. So now what we need to do is we need to loop through, we need to create a new variable. I'm going to call it hold. We need to loop through our original stock time. So for I in stock time, or no, what if we do I in DW? That would give us we'll call it IDX equals stock time dot index I print IDX. Let's see what that does. Oh, what do you know? There's an error. Oh yeah, so for this we need the try catch, whatever you want to call it. past that for now. Okay, so that's not supposed to happen. How about if I do ST? ST DW index. Okay, got it. So I'm gonna do hold.append IDX. Now I think this will work. Enumerate hold print stock ticker I DWJ. Whoa, they match. They match. This is good. This is good. The algorithm worked. Now we gotta construct the data set to match it. So for that, I'm gonna comment this out. Just keep it there for reference because it's very important. I'm gonna call this S for stock, C for crypto, and B for both. And they all equal an empty list. Now what we're gonna do is we're gonna do s.append, and since these should be lists, it's gonna be SCI plus CCJ. And I'm going to turn S to a NumPy array so I can get the dimensions and stuff. Index error. List index out of range. Okay. So I've had this error many times, and it could just require like eliminating a crypto coin from our set. So for that, I'd actually go here for I, and it's usually crypto. I'm going to zip this so I can get the ticker too. Print length of I J. Oh yeah, so this is why they don't work. They're not all the same length. What we could do, honestly, let's just do this. Let's cut them down to all equal. Well, we should probably take a look at the stock ones too. No, for this, let's just do it raw, like 440. And this will also be 440. So let's rerun all this. Still list index out of range. Okay, that seemed to work. The for loop on the stock prices, but the crypto prices. Oh, we got the same error. No, we're going to go through this error right now. We're going to solve this error. It's going to take a little while, but bear with me. What is this? See, this is actually a good learning experience for everybody watching. Like, we're learning this together. We just need to... I'm just going to hit a pass on this for now. It has to do something with the way that this was indexed. Print length of hold. Okay, 1,258. It's not supposed to be doing that. Oh, and you know why? Because these weren't indexed by 44. Okay. Actually, this is what I'm going to do. I'm going to create a variable, call it stop, call it 420. So stop, take this out, because I don't need that anymore. Stop, and then stop with less. Okay, so I don't need to rerun the data. I'm going to run this again. Okay, so it printed the length of hold, so it should work. Now I want to check my dates again. Make sure every one of it matched. Let's see how far this goes. 7/7, July 7th, 2021. Okay, everything's good to go. Because you don't want to, like, for these type of, like, the algorithm that I'm going to be showing you later in this video is like, you don't want it depending too much on anything past like a year. You know, this is going all the way back to like just 1 year ago, so we should be good. But now let me comment this out again, and I'm going to do s.append sci plus d no plus ccj. List index out of range again. What's wrong? Oh, I forgot to transpose. Okay. They don't really need to be np dot. Okay, sc equals np dot array sc transpose dot toList cc equals np dot array cc dot transpose dot toList. Still giving it. Oh, name numpy not def. Oh shit. I don't want to redefine everything, so I'm just going to import numpy here. Okay, I think it worked. Let's see now. This would just be crypto, and then. Oh, okay. So both is a SC and CC. Stock is S. Okay, now do I want these as numpy arrays? Yes, I do, yes. So I'll call this both crypto and stock. Let me just make sure I don't have any duplicates. Okay, yeah, I have a duplicate, so I gotta call it something else. I'll call it cryptocurrency and stock market. Okay, so I want to print the shape out of all these before I continue. Two 291, and then 14 columns, 7 columns, 7 columns. Sweet, we got it. Now the next thing to do is calculate the rate of return for all of them. So that will be, I'll do this, ROR both equals both ROR both ROR crypto what this is doing is cutting out the last element because the data is organized from newest to lowest. So the last element needs to be eliminated. So in order for the previous last value to be able to divide to calculate the rate of return. And yeah, this is since they're NumPy arrays, I could directly do like a matrix algebra function like this on them. And then ROR stock market go ahead and enter on that. Okay, so I got my rate of return variables, and now that we did all this, we cleaned up the data. Now we got to define our math functions. So I'm actually going to create this as a markdown cell, call it portfolio optimization. And I'm going to say the purpose of this program is to view the efficient frontier curve for all stocks and cryptocurrencies along with individual curves for stocks and cryptocurrency. Just add a BR so I could write some more. Okay, so portfolio optimization. The purpose of this program is to view the efficient frontier curve for all stocks and cryptocurrencies, along with individual curves for stock and cryptocurrency portfolios. So the first thing I'm going to do is create a markdown. I'm going to show you just exactly what we mean by that with this function. So we're going to be optimizing this program, and this is the matrix algebra formula that must be computed. So we begin, or actually I'll define some big matrices. Got that there. Now we want to do begin matrix. And I'm not going to get into like the whole derivation of it. I'm just going to show you what the matrix is. Okay, so our first element is going to be 2 sigma. Our second element is going to be mu. And our third element is going to be 1. Now to the next row, we have mu transpose. And then 0. And then 0. And then we have 1 transpose. And then 0. And then 0. Let's see if it printed out. Yes, it printed out. And we are going to be taking the inverse of this matrix and multiplying it by by this vector. Sometimes I think LaTeX is harder than Python. But let's see, where the first element is 0, or rather a vector of 0. It's not an element. But R sub t is the next element, and then 1. I made a mistake somewhere here. What did that make? Oh, I didn't declare this as a matrix. Yeah, see? LaTeX is harder than Python. Oh wow, I made a I made a column vector there. Got a row vector. Okay, so this is the linear algebra formula that we're trying to solve. The sigma right here is our covariance matrix, and for those of you who don't know what covariance is just a strength indicator of how much two or more variables move with each other. Two variables. And then mu is just the average rate of return of the stock. That's what we're going to be calculating in a minute. And then the 1 is just there to make sure that all the weights of each allocation in each stock or crypto adds up to 1. So let's see. Now I'm going to define a function called def mu sd, put x in it, and it's going to require a numpy array, which is both of these. So this is going to return 3 variables: the standard deviations, the means, and the covariance matrix, because we're going to need all of them later in the program. So first we take the shape to get the dimensions, and for mu it's just 1 divided by m times np.1's m dot x. And I'm going to do this. So it's going to be sd mu. What's the first? Oh, it's sd both, mu both, and covariance both equals mu sd ROR both. So let me just go ahead and return some random variables until we get there. But we want to be able to print out our mu, and as you can see, we have our mu. Now let's do mu.shape 14, because that's 7 stocks, 7 cryptocurrencies. Okay, so now covariance equals 1 divided by m minus 1, because this is a sample technically, times x minus mu dot transpose dot x minus mu. Now let's print our covariance. Should be a 14 by 14 matrix. We can verify with dot shape. Yep, that's what it is. So now we got that. Now we need the standard deviation, which is simply the square root of the diagonal covariance. Now print standard deviation just to make sure. Check the shape. Yep, 14. So now we have our mu sd function. It's going to be standard deviation mu covariance. So now the next function we're going to be typing in is the optimization function, this linear algebra problem. And we're going to keep this here for the time being, just to, I guess it could just be in this particular cell too. It's not, because you need you need these values too. So I'm going to cut this out for a second. Or no, I'm going to comment it out. And I'm going to write def optimize. So that'll include x and r. That's the 2 arguments. This r of t, that's an argument. So first we need to compute our mean and everything. That'll make it a bit easier. Now that we have that, we need I'm going to call this cov. Because you see how you got that 2 sigma there? We're going to create that right now. 2 times cv dot toList, because we need to convert it to a list so we can append values to it. I think it's immutable if it's just stuck as a numpy array. But okay. Now for I in range length cov I dot append. You see, we're converting the mu is a vector, and that's why it's transposed like that, and the 1 is a vector too, and that's why it's transposed like that. So we're going to be doing cov I dot append mu I, and then cove. I hate when my laptop does that. Okay, I got it back. Cove I dot append 1. You're building this outer layer, and this is the same dimensions, just transposed. And what I mean by that is we come here and we do cove dot append mu dot to this plus 0, 0. Because you see, you got 3 elements in the row, and then a 0 and a 0. And cove dot append np dot 1's length of cove plus 0. Oh wait, let me do 2 list plus 0, 0. Now we want to print cove. Oh, wrong. Wrong again. Oh, that's why it's not working. It needs to be called. So I'll do optimize both RO. Oh no, ROR both. And then I'll just put 1%. Okay, there's an error. Let's run this. Oh, I see. All right. Well, we reach another roadblock, but we can get through it. Let's why don't we do this? Delete all this. Print code. Okay, so that function works. For what's the no. Okay, I'm gonna keep the shape down there. Okay, so it's now it seems to be working. Could it be the mean? Okay, it seemed to have added that on. Oh, cool. Sometimes these touch bars are too sensitive. Okay, so we got a full 16 length array. Let's call this Z. Print Z. Okay, wow, that's big. So I'm gonna create another variable now. Call it y equals np dot array 0 for I in mu. You just need something that's 3 dimensions. Plus r, comma, 1. That's building this vector right here. This is the vector of zeros, but it still has to be formatted as one column. Well, yeah, we got that. Now we return np.linalg.inverse z, because you see this -1 here, that's taking the inverse of this matrix, dot y. So now what should I call this? Oh wait, I need to delete the last two elements of this because they're these two variables called Lagrange multipliers, but we don't really need them. The first couple are our weights. So I'm gonna call this W weight both. Now print W both. And yeah, these are your weights for each stock. Notice you can go long, short, use leverage, anything to get the perfect portfolio. Okay, so we got that down. Yeah, I need to. So now we can collect all the variables. I'm going to need these for plotting. SD C MUC. So got the crypto data, and then the stock, we'll call it SDS MUS CVS equals MUSD ROR stock. Got it. Now we want the weights. Actually, no. Oh, we still have to create the function that gives you the portfolio curve. These will just return you values. And actually, no, I'll keep these down here. Def efficient front. So input that, you need your weights now. I'll just call it X. SD mu CV equals mu SD X. I need the mean for this one because I'm going to do M0, M1 equals NP dot min mu, NP dot max mu. Our n number of line points is going to be 30. So dm, which is the rate of change, is m1 minus m0 divided by n minus 1. Now for I in range n, our rs, which is our return that we're plugging in, is going to equal m0 plus I times dm. Now our weight is going to be, oh wait, I should also add ux, uy equals empty brackets because we're going to be returning this line as a list. So optimize x rs, and let's see what to call it values. Our x is going to be standard deviation. So we're going to be doing, or no, let me call it first. Efficient front. I'll do them both, like for all. So then that would be standard deviation equals weight dot transpose dot CV covariance matrix. Okay. And I believe it returns 2 zeros. And our mean is weight dot transpose dot mu. I just hope I'm doing this right. I don't want to mess up again. But yeah, so print. Oh yeah, it did work. Of course, we have no negative numbers in the x-axis because that's the standard deviation. It's taking the square root essentially. Oh, actually, let me just add that. Yeah, even better. So now that we got those two, we could store them as ux.append standard deviation, dy.append mean, and return ux uy. Okay, I think we've declared everything we need from this. I'm going to now I think we're ready to plot. Yeah, I think we're ready to plot. So let's see. We got the plotter open right here. No, we don't. We never imported it. Okay, so import matplotlib.pyplot as plt. Fig equals plt.figure. Ax equals fig.add subplot. I'm gonna change the fig size. So I want it to be wide. We'll do 9, 9. Let's see how big it is. No, this is a big enough graph. Oh, that's. Okay, this is perfect. Yeah, perfect size plot. Maybe. Yeah, okay, this is better. So now we want to plot. First, we need our tickers. And this time it's just going to be stock tickers plus crypto tickers. Okay, just making sure. Okay, so little stumped right now, just trying to figure how to. Okay, ax dot scatter. How to. Sometimes my keyboard has a mind of its own, but sdb mu b color equals blue. Okay, so these are all the stocks and assets. Now what I got to do is go for ticker ux, uy, and zip. Oh, wait. I got to bring back that. Yep. I'm sorry if I keep going back and forth. I just needed to remember these variables. I haven't had. So tickers sdb mu b ax dot annotate. This is what writes a comment right on your dot. And this time it's going to be our ticker xy equals ux uy. And there you go. We got our assets labeled. Now we can see all the stocks over here, lower risk. You can see crypto over here. And look, you got Sol USD as a high return. I wonder what happened there. But let's draw our efficient frontier lines now. So SX, SY is going to be, or no, just to keep them grouped. SBX, SBY is going, I'm gonna call this EF. I don't want to type out the whole thing. Oh wait. For the arguments, just X. All right, that's a little too bright. We'll do green. So this is our first efficient frontier line telling us the efficient portfolios in each of these in every asset or coin on here. But I want to look at the other ones too. So that'll be, let's see, these are all fine. SCX SCY equals EF ROR crypto. Make that red. Okay, so this is the efficient frontier of the crypto. Now we gotta do the stocks. So SX SSY equals EF ROR stock. X dot plot SX SSY color equals orange. Alright, so we got our efficient frontiers. This is how you do mean variance analysis, risk return. Seems like crypto's much higher in risk right now versus the stocks are doing something like Apple, Microsoft, anything above like this line is doing okay. Like they got a positive return, so they may, like some of these other coins like Ethereum, Zcash, they may be like worth the risk, maybe. All right, thank you for watching. Bye bye.